Hello grade 7 students, welcome to my channel. I'm Mrs. Navodha. In this video, I'll teach you the first lesson of your math textbook which is about symmetry. Before starting this lesson, let's see what you are going to achieve after learning this lesson. Firstly, you will be able to identify symmetrical figures and non-symmetrical figures. I'll describe this word later when it comes to this topic, bilateral symmetry. Secondly, you will draw the axis of symmetry of a symmetric figure. And finally, you will create symmetrical figures by yourselves. Okay, let's get started then. First of all, what is symmetry and how we are going to identify symmetrical figures? Okay, now, symmetry is like when you fold some figure in half and if both sides look same, then we call it a symmetrical figure. Or we can say it has symmetry. Easy, right? Okay, then let's read this topic. Bilateral symmetry. Bi means two. So bilateral symmetry means figures which have two equal sides. Or we can say figures which have two sides that are coincide with each other perfectly. To understand bilateral symmetry, let's check out this figure. Now you can see it has four sides, 1, 2, 3, 4. Therefore, we call it quadrilateral shape. Quadra means 4. So, quadrilateral shaped, by that word, you can get an idea that shape has four sides like this. Okay, so the quadrilateral shaped card is given here, and by folding this figure along the dotted line, we obtain two parts that coincide each other. Simply coincide means the parts match or align with each other. Now let's check again this image. By folding along this dotted line, you will get two equal parts. This is 1 and this is 2. So you can see these two parts are equal to each other. Therefore, we can say this image has symmetry. Okay, let's do some activities. Now turn the next page and there you can see four figures are given. Now I'm going to copy all these figures and check whether they are symmetrical or not. I have drawn and I have cut these figures along the edges. Now what I'm going to do here is fold each of these figures separately. Let's start with the first figure. We have a leaf shape. Now I'm going to fold this one like this. And now you can see the edges are perfectly aligning with each other. And we can say also these two sides are perfectly coincide with each other. So that means this figure has symmetry, or we can call this is a symmetrical figure. Let's move on to the second figure. We have a rectangle here, and now I'm going to fold it in a way that opposite sides meet with each other. Opposite sides mean these two are opposite sides and these two. So let's try both ways. Now you can see these two sides are coincide with each other perfectly. And I'm also going to try to fold in this way. Okay, you can see still these two sides are coincide with each other. That means rectangle is also a symmetrical figure. So in the first figure, we got only one line, this line. But you can see in a rectangle, we got two lines, this line and also this line. Right, we got two lines there. Next, we have a star. Let's check, is this symmetrical or not? So I'm going to fold it like this, and I got two equal sides. Or I could say these two sides are coincide with each other perfectly, which means the star is also a symmetrical figure. There are other several ways to fold this. Yeah, I could fold it like this, and I could fold it like this as well. So let's see how many lines we got here. So we got 3 lines for the star. This specific line has a name. We'll come to that in a bit. Okay, our last figure is a circle. Now let's check out what you think about the circle. Is it symmetrical? Let's find out. Okay, I'm going to fold it like this. Of course, it's symmetrical. You can see these two sides are coincide with each other perfectly. Okay, I got one line here and I'm going to fold it like this. So I got two lines. I can get many lines as I want. So this is line 3 and let's fold it in another way. And this is line 4. For the circle, there are many lines like that. We can't get exact number for a circle. I drew dotted lines along the folding. So now you can clearly see it. And do you remember, earlier I mentioned these specific lines have a name. Yes, these lines are called axis of symmetry. Okay, now let's get back to the textbook. There are so many symmetrical objects in the environment. Three examples are given here: a Christmas tree, a butterfly, and a leaf. Once you copy these figures, you can divide these figures into two equal parts. We have already discussed about these four figures. Now let's move on to activity 1. Step 1. You have to trace this figure onto a paper and cut it along the edges like in figure 1. And in step 2, you have to fold this figure and get two equal parts like in the figure 2. And in step 3, you have to draw a dotted line along the folding. Okay, now let's do this activity. Here I have traced and cut the figure. Now let's fold it. Since we got two equal sides, we can say this figure is a bilateral symmetric figure. And when you unfold it, you can see there is a line along the folding. What we call this line? Yes, we call this line the axis of symmetry. Let's read this highlighted area. If a plane figure can be folded along a straight line so that you get two parts which coincide, then that plane figure is defined as a bilaterally symmetric plane figure. The line of folding is defined as an axis of symmetry of the figure. So basically, it says that by folding a plane figure, if you could get two equal parts, it's a bilaterally symmetric plane figure. And the folding line we define as an axis of symmetry of the figure. Consider this figure again. By folding along this dotted line, we get two equal sides. Therefore, we call this is a bilaterally symmetric figure. And this line we called the axis of symmetry. Now let's review previous examples again. All these four figures are bilaterally symmetric figures. Why is that? Because by folding them along these dotted lines, we got two equal parts that coincide with each other. Bilateral symmetric figures can have more than one axis of symmetry. Here we got one axis of symmetry for the figure 1. Next one is a rectangle and we got two axes of symmetry for that. And for the next figure we got three axes of symmetry. This is 1, this is 2 and this is 3. And the next one is a circle. It has more axes of symmetry. What do you think of the reason for that? It's because a circle has no edges or corners. As long as lines pass through the center, we call them axes of symmetry of the circle. So therefore, the circle can have infinitely many axes of symmetry. Let's move on to the next page. There is a rectangle given and we know a rectangle is a bilaterally symmetric figure with two axes of symmetry. And here I'm playing the previous video clip to memorize it for you. Here they have given another dotted line. It has been drawn by joining opposite vertices. What are vertices? Now I am drawing two lines. And the point where these two lines meet we called a vertex. Vertices is the plural form of the word vertex. Simply, you can say vertices are corner points where the sides meet. So, for a rectangle, you can see there are four corner points: 1, 2, 3, and 4. So, how many vertices for the rectangle? There are four vertices for the rectangle. Okay, now let's get back to this dotted line. What do you think will happen when we fold this figure along this dotted line? Will the sides coincide? Let's figure it out. I'm going to fold along this dotted line. Let's see what happens here. No, this is not an axis of symmetry because once I fold it along this dotted line, you can see the other side from here. Because of that, because the two parts are not overlapping, we can say this dotted line is not an axis of symmetry. Now let's review what we have learned from here. Just because the size and appearance are same, we can't determine these figures are symmetrical. We have to make sure by folding it along the given dotted line to see if it coincides. So remember, looking alike is not enough. It must coincides. So what I just mentioned here is on your textbook. Now let's read that paragraph. Let's read this paragraph. A line through a plane figure which divides it into two parts of the same shape and of the same area which do not coincide with each other is not an axis of symmetry of the figure. Drawing axis of symmetry. Let's do this activity number 2. Step 1. Copy the figures given below on a piece of paper and cut out each lamina. Lamina is another word for the plane figures. Step 2. Find the bilaterally symmetric figures from the figures that were cut out. And in step 3, draw all the axes of symmetry of the figures with bilateral symmetry. And in step 4, you have to paste all the figures having axes of symmetry in your exercise book. Okay, before starting this activity, shall we do some guesses? Guesses about what are the symmetrical figures and what are the non-symmetrical figures are. Here I have drawn dotted lines in all figures, and you can see areas and sizes of the two sides that are separated by these dotted lines. They look same in every figure. This side and this side, this side to this side, this side and this side. Even in these two figures, this one and this one, you can see that the two areas that are separated by this dotted line looks same in size and shape. But just from that, we can't decide that all these figures are symmetrical. We have to check whether these parts are going to coincide or not. Since we are only guessing here, I think these six figures are symmetrical and these two are not. Let's find out. I'll leave these two figures for the end. Let's start with this figure. Two parts are coinciding with each other perfectly. So this is a bilaterally symmetric figure and it has only one axis of symmetry. This figure is also symmetrical and it has two axes of symmetry. Okay, let's fold this one. Yes, this one is also a bilaterally symmetric figure. You can see that, and it has one axis of symmetry. Okay, next we have a rectangle, and already you know it has two axes of symmetry. Here we have two axes of symmetry. Let's try this one. Yes, it's a bilaterally symmetric figure and you got only one axis of symmetry. Okay, next we have a square. So the square has four axes of symmetry. Now I'm going to fold these two figures. Let's start with this one. You can see it's not coinciding. You can see the other part from here. So this is not a bilaterally symmetric figure. What about this one? It's not coinciding either. Now you may have understood that even though the two parts are equal in size and appearance, some figures are not coinciding, like these two. So all my guesses were right about earlier. And do you want to know the secret? Of course, I'll reveal it to you. You know, when you get such questions in exam, you may not have time to copy figures and then fold it to know whether they are symmetrical or not. So this way is easy. And also you could try this method on your exams. Now let's get back to these two figures to understand that easy method. First, think about possible lines and draw them on the paper. Now think, if you are going to fold along this line, these two sides are supposed to align with each other. This side and this side. But you can see this line is shorter than this line, or this side is shorter than this side. So these two sides are not aligning. That means this dotted line is not an axis of symmetry. Simply like that, without cutting and folding the figure, you can figure it out if it's bilaterally symmetric or not. Now think about this figure in the same way. Start with here. The distance from here to here and here to here is not equal. So there is no way this could be a bilaterally symmetric figure. Let's discuss exercise 1.1. From the following, choose the bilaterally symmetric figures with the correctly drawn axis of symmetry and write down the corresponding letters. Okay, you have to write down the corresponding letters of the figures that are bilaterally symmetric with the given dotted line. Now let's look at first one. 1, 2. 1, 2. So it's 2 squares away starting from this point on either side. So it's symmetrical. And the second figure is a rectangular, and we know it's also a symmetrical figure. Okay, next figure. 1, 2, 3. 1, 2, 3. So it's 3 squares away starting from this line on either side. That means it's also symmetrical. Here you can easily recognize this is not a symmetrical figure because of the size difference in the two sides. So D is not symmetrical. What about E? E is a rectangle. We know a rectangle is a symmetrical figure, but with this given dotted line, these two parts are not going to coincide. Because of this given line is not an axis of symmetry. So this is not a bilaterally symmetric figure in that case. This dotted line is also not an axis of symmetry because these two sides are not going to coincide. But next one is a symmetrical figure. It's a square, four sides are equal here, and we know that folding along this diagonal can give us two equal parts. Here let's count squares starting from this line on either side. These 2 points, this one and this one, are 2 squares away. 1, 2, 1, 2. These 2 points are 1 square away. 1, 1. And these 2 points are 3 squares away. 1, 2, 3. Starting from here, 1, 2, 3, which means both sides are the same in size. And also when you look at the lines that are supposed to align with each other, they are equal in length. This side equal to this side. This side equal to this side. This side equal to this side, and this side equal to this side, like that. So a H is a symmetrical figure. This figure is not symmetrical. Two sides do not look alike. So I is not symmetrical. But J, K, L, these three figures are symmetrical. You can see that by folding with the given dotted line, you will get two equal parts. Question number 2, Room number 1. Cut out laminas of the following shapes using a tissue paper. Draw all the axes of symmetry of each of them. Room number 2. Paste all the figures having axes of symmetry in your exercise book. Let's do that. Here I have cut 4 laminas. Let's start with this one. It has only one axis of symmetry. Now let's look at this figure. Do you remember there is a name for enclosed plane figures with four sides? Yes, we call quadrilateral shape. Let's see what happens when you fold it. You can see the two parts are coinciding with each other perfectly. That means this is a bilaterally symmetric figure. Now we got two axes of symmetry for this quadrilateral shape. Therefore, this has a special name. We call this a rhombus. That is why this shape has symmetry, because all the four sides are equal. These four sides are equal to each other. There are two diagonals here. By these diagonals, rhombus divided into two equal areas. Next, we have a lamina with 6 sides. 1, 2, 3, 4, 5, 6. So we call this is a hexagon. Let's fold it. And you can see it's perfectly coincide with each other. Therefore, this is a bilaterally symmetric figure. Now let's find out how many axes of symmetry this figure has. Okay, we have one, and this way we have two axes of symmetry. Now that I fold it like this, you can see these two sides are not overlapping with each other. We can see some part of the other sides from here. That means these two are not coinciding. Why did that happen? Let's figure it out. Look at these two sides while I'm folding it. Once I fold it, see, if these two sides are aligning with each other, then we can get two equal parts. But here you can see these two sides are not aligning with each other. So that means the length of these two sides are different from each other. So for this hexagon, we got two axes of symmetry. Furthermore, if all these 6 sides of this hexagon were equal to each other, then you will get 6 axes of symmetry. In that case, we call this is a regular hexagon. Finally, we have a curved shape. It has only one axis of symmetry. Question number 3, row number 1. Cut laminas of the following shapes using paper. Draw all the axes of symmetry of each of them. A is a rectangular shape, B is a triangular shape with two sides of equal length. What we call triangle with two equal sides? We call isosceles triangle. Row number 2, write the number of axes of symmetry in each of the above figures. Row number 3, create another symmetric figure by joining two figures of the shapes given in A and B above and paste it in your exercise book. Now let's do that. Here I have cut the figures. Now let's fold. So there are two axes of symmetry for the rectangle and one axis of symmetry for the isosceles triangle. In row number 3, you have to create another symmetric figure joining these two. So when you are joining these two figures, make sure the axes of symmetry in both figures align in a straight line. Now I am placing this figure like this. Now you can see the axis of symmetry of the triangle is aligning with the axis of symmetry of the rectangle. We got an arrow shape here, and this is the new axis of symmetry of this combined figure. So this is a one way to place it. You can also place it like this. Question number 4. Write the statements below in your exercise book. Mark a correct sign in front of the correct sentences and a wrong sign in front of the incorrect ones. Look at the first one. In a bilaterally symmetric figure, The two parts on either side of an axis of symmetry are equal in shape and in area. That's true. Two parts are equal in shape and area. That's why they are coinciding. Problem number 2. There are bilaterally symmetric figures having more than one axis of symmetry. Of course, there are a circle, rectangle, square. Those are some of examples for that. Problem number 3. The number of axes of symmetry in a circular lamina is greater than the number of axes of symmetry in a square. Yes, that's true. We know square has only 4 axes of symmetry and circle has more. Rome number 4. The maximum number of axes of symmetry in a bilaterally symmetric figure is 1. No, that's incorrect. Maximum you can have more, but minimum there should be one axis of symmetry. Problem number 5. If a bilaterally symmetric figure which has at least two axes of symmetry is cut along one axis and divided into two equal parts, then each of these parts too will be bilaterally symmetric. Yes, that's true. Here is a little demonstration to explain this.
Consider a rectangle, for example. When you cut along this line, you will get two equal parts. Then you can fold these two parts along this line and they will coincide. See, it's coinciding, and also this one is coinciding as well.
So far, we learned about how to identify bilateral symmetric figures and how to draw an axis of symmetry. Now we are going to learn about how to create bilateral symmetric figures. And there is an activity in your next page. So this activity is about creating plane figures having bilateral symmetry.
Activity 3. First, take a piece of paper of any shape and a pair of scissors. Then fold the paper into two. Okay, let's fold it. Next, draw any figure of your choice such that it contains a part of the line of folding and is limited to the area where the two portions overlap. Now let's draw any shape we want. My folding line is on this side, so I am starting with this side. Now let's cut out and see what we got here. Let's unfold it. I got a shape of a teddy bear's face, and this folding line is the axis of symmetry of this figure. Activity 4. Take another piece of paper and fold it twice so that you obtain a right angled corner. Here I have a piece of paper and I am folding it in half. And now I'll fold it in half again. So I've obtained a right angle corner here. Step 2. Now draw a figure on this paper so that it includes the right angle corner and such that it is limited to the region where the four portions of paper overlap. Then you have to cut the figure and unfold it. You will obtain a bilaterally symmetric figure with two axes of symmetry, where the axes of symmetry are the two lines along which you folded the paper. You can draw any figure you want. I am going to draw the figure in the textbook. So remember where the right angle corner is. So it's in here. Let's draw. This is a right angle corner. It's 90 degrees. Okay, let's unfold it. Now you can see there are two axes of symmetry in this figure. So in this way we can obtain a bilaterally symmetric figure with two axes.
Next we have activity 5. Let's do it together. You will need a paper and some paint.
First take a piece of paper and then fold it. Here I have some paint. Now let's unfold this paper, and this is the side that is folded in. Now I am going to place a drop of paint here on the folding line. Let's fold the paper back and press with your hand where you place the paint. So I am applying little pressure here to this direction, and to this direction I am applying little pressure, and also to this side. So let's unfold and see what we have got here. So we got a bilaterally symmetric figure with the paint, and the folding line is the axis of symmetry.
Next, you have an assignment to do. Create various bilaterally symmetric plane figures by cutting out folded paper as well as by placing drops of paint on folded paper as done in the previous activities. Prepare an attractive wall decoration using the symmetric figures that you created. You can do that, and this will be a great idea to decorate your study place. Let's move on to the next topic, drawing bilaterally symmetric plane figures. Now look at this diagram. This line is the axis of symmetry of this figure. A, B, C, D, D dash, C dash, B dash, and A dash are vertices. We know vertices are corner points or edges. That's where straight line segments meet. Segments. Segments mean parts of line. Usually we use capital letters to name the vertices. So everything I mentioned is in the first paragraph. You can see here the axis of symmetry of this figure is the vertical line indicated by the dotted line. This is the axis of symmetry. The points at which the straight line segments of a rectilinear plane figure meet are defined as the vertices of the plane figure. Usually the vertices are named using capital letters of the English alphabet. So you know what are the vertices are, and also you know we named vertices using capital letters of the English alphabet. Let's read the second paragraph. The vertices A, B, C, and D are on the right side of the axis of symmetry of the figure. Let us consider where the points A dash, B dash, C dash, and D dash are located on the left side of the axis of symmetry. You can see that A, B, C, D vertices are located on the right side, while A dash, B dash, C dash, and D dash are on the left side. Okay, now let's learn about corresponding points or similar points. Look at A dash, it's one square away from the axis just like A. So A dash is similar to A. We can say A dash is the corresponding point to A. Similarly, B dash is the corresponding point to B. Let's say it together. C dash is the corresponding point to C. D dash is the corresponding point to D. Very good. But all these are vertices. A, B, C, D, A dash, B dash, C dash, all these are vertices. So we can say A dash is the vertex corresponding to A. Let's say it together. B dash is the vertex corresponding to B. C dash is the vertex corresponding to C. D dash is the vertex corresponding to D. Very good. It is mentioned in your third paragraph. A dash defined as the vertex corresponding to A. Okay, now let's learn how to draw bilaterally symmetric figures. Turn to next page. There is an activity for you. Activity 6, Step 1. As indicated in the figure, select the vertical line on the grid and mark it with a dotted line like this. In step 2, you have to select 3 points of intersection of vertical and horizontal lines on the grid which lie on the left side of the dotted line. Name these points as A, B, and C respectively. First of all, let's learn about these words: intersection, vertical, horizontal lines. Vertical line goes up and down like this, like a tall building. horizontal lines stretch out like a long, flat road. So these are horizontal lines. Now look at these points where horizontal and vertical lines meet. We call such points intersection points. What we call them? Intersection points. Good. Now let's get back to the activity. Here I have drawn a vertical line. Point A is 3 squares away. 1, 2, 3. Point A is here. Point B is 2 squares below. 1, 2 and 1 square away. So point B is here. Point C is 4 squares below. 1, 2, 3, 4 and 3 squares away. 1, 2, 3. So it's here. In step 3, we have to join points A and B and C using straight line segments. In step 4, they ask to mark corresponding points to points A, B, C. So point A dash also 3 squares away, just like point A. Point B dash is also 1 square away, just like B. Point C dash is also 3 squares away, just like C, like this. Now let's join these points A dash and B dash, B dash and C dash. In step 5, join the points A and A dash and the points C and C dash using straight line segments. Now we have obtained a bilateral symmetric figure, and this dotted line is the axis of symmetry of this figure. There is example given in next page. So let's discuss it. We have to complete this bilaterally symmetric figure considering this dotted line is an axis of symmetry. So they have given 4 points A, B, C and D. What we have to do here is mark the corresponding points of A, B, C and D. Let's do that. Point D is 1, 2, 3, 4. 4 squares away. So point D dash 1, 2, 3, 4 is also 4 squares away. It's in here. Point B is 3 squares away, so B dash is here. Point C is 6 squares away, so C dash is here. Point A is 3 squares away, so A dash is here. Now let's join these points D dash and C dash, C dash and B dash, B dash and A dash, then A dash to the axis of symmetry, D dash to the axis of symmetry. So in this way you can obtain a bilaterally symmetric figure using your squared ruler book. Next we have exercise 1.2. Copy figure A in your square ruled exercise book. The dotted line indicates the axis of symmetry. Place a mirror on this line and observe the bilaterally symmetric figure. You can do that. You can place a mirror along this dotted line, so you will see the same shape in the mirror. Problem number 3. Draw and complete the bilaterally symmetric figure. Okay, now let's draw. Just copy what you can see here on the right side. Copy the same thing and draw them on the left side. 1 squares to this side. So 1 squares to this side. And 1, 2, 3, 4, 5 squares down. So here 5 squares down. And 1 square to this side and 4 squares up. Repeat the above steps for figure B and complete the bilaterally symmetric figure. 2 squares down, 2 squares down, 2 squares to the left side, 1 square down, 2 squares to the right side, 1 square down, and then connect. Draw a bilaterally symmetric figure with the points marked on the grid as vertices and identify its axis of symmetry. First, connect these points. Now you can mark the axis of symmetry like this. Copy each of the figures given below in your exercise book. Complete the figure so that you obtain a bilaterally symmetric figure in each case. So let's copy the figure 1. First draw the axis of symmetry. It's 1, 2, 3, 4, 4 squares down. Now mark vertices. This one is 2 squares away and 1 square up. 2 squares away and 1 square up. So this is the vertex. Now let's connect with straight line segments. Now let's do the same thing to the left side. Next one, let's start with the dotted line. 1, 2, 3, 4, 5, 6. So the size is 6 squares. Next, mark the vertices. 1 square up. So it's here. This vertex is 1, 2, 3, 4. 4 squares up and 2 squares to the left side. So 2 squares to the left side and 1, 2, 3, 4. 4 squares up. It's here. This one is 1 square up. It's here. And the next one is here. Now let's connect these points. Mark vertices on the other side. 1 square down and 4 square down. So here 1 square down. Now take the ruler and connect these points. So you got another bilateral symmetric figure. Next dotted line is 1, 2, 3, 4, 5, 6. 6 squares in length and it's a vertical straight line. Now let's mark vertices. This point is 2 squares away and 2 squares below. So 2 squares below here and 2 squares away. So the point is here. And see the next point. This point is half of squares away. So it's here. Now let's connect these vertices. Copy the same thing on the other side. Let's start with the axis of symmetry. 2 squares up. From here 2 squares up. 2 squares to this side. 2 squares to this side. And now let's connect these 2 points. Copy the same vertices and lines on the other side. Next one I am starting to draw from this line. This line goes up and it's 1, 2, 3, 4, 5. 5 squares and 1 square away to this side and 2 squares up. Starting from here 1, 2, 3, 4. 4 squares away. Now I'm going to draw the axis of symmetry. This one is a little bit different from other 4 figures because it is an inclined line and it goes through the intersection points. You can see that. That means the line that's supposed to align with this vertical line is horizontal. So the size of this vertical line is 1, 2, 3, 4, 5. 5 squares. And now I'm going to draw a horizontal line 5 squares away from here. And there is a line to this side. I'm drawing a line inward to this side. And this is 2 squares away and it is a vertical line. So this would be a horizontal line. So all you have to do is draw this line, join them like this. Next question. Trace each of these figures given below on a tissue paper and copy them in your exercise book. To get the exact shape on the other side, you have to trace this one using a tissue paper. So once you traced it, turn the tissue paper on the dotted line so you can draw easily the other half. Here I'll just use my hand to draw and show you what kind of shape you will get by tracing. So it would be like this. And the next figure, something like this. And the next figure, something like this. Question number 5. Draw 3 bilaterally symmetric figures on a square ruled paper such that each figure has only one axis of symmetry. Problem number 2. Draw the axis of symmetry of each of the above figures. Here you are free to draw any kind of bilaterally symmetric figures. I'll start with the axis of symmetry. Next I'm going to mark vertices here, here, here and here. So now I'm going to mark the corresponding vertices here. This one is 3 squares away, this one is 2 squares away, and this one is again 3 squares away. Next, you can join these points. Let's draw another one. This time I am drawing horizontal line for the axis of symmetry, and this time I'll choose three vertices here, here and here. So this one is three squares up. Let's mark the corresponding points. This one is two squares up. Then it's the corresponding is here. This one is three squares up. So the corresponding is here. Now let's join these points. Let's mark several points on this side here, here and here. So let's mark the corresponding points here, here and this one is three squares away. So it's here. Now let's connect these points here to here, here to here, here to here and here to here. Like that you can draw any kind of figure. Question number 6. Draw two bilaterally symmetric figures on a square ruled paper such that each figure has only two axes of symmetry. So this time the figures should have only two axes of symmetry. Draw the axis of symmetry of each figure. Here I suggest you start with two axes of symmetry. 1, 2, 3, 4. There are four sides. So now try to draw same thing on the four sides. First I'll mark points on one side. I'll mark one point here, three squares away. And the other point is here, it's five squares away from the vertical line. Now let's copy these points on the other three sides. Two squares up, then two squares down. This one is three squares up, then three squares down. So this one is three squares away. And one point is here, the other point is here. Three squares away, and this one is five squares away. Let's connect these points using a ruler. So you will get a figure with two axes of symmetry. Let's draw another one. Again, I'm starting by drawing two lines. These are axes of symmetry of the figure. Now let's try something like that. From this point, two squares away here. From this point, two squares away. From this point, two squares away to this direction and to this direction. You can draw something like this. Okay, now the exercise is done. Now there is a summary. Let's read it. If a plane figure is divided into two equal parts which coincide with each other when folded along a particular line, then that figure is defined as a bilaterally symmetric figure. The line of folding described above is an axis of symmetry of the figure. Okay, this is the end of the lesson. I hope you find it useful. Subscribe and click the notification so you'll be notified when I upload more lessons. Thank you everyone. See you in another video.